Hello friends, I welcome you in lecture number 11 on series solutions of differential equations. We have seen general formula for Legendre polynomial of degree n, and let me recall that formula. We know that Pnx is given by this summation sigma r equal to 0 to capital M minus 1 raised to r times 2n minus 2r factorial. Here we have 2 raised to n r factorial n minus r factorial times n minus 2r factorial into x raised to n minus 2r, where capital M is n by 2 if n is even and n minus 1 by 2 if n is odd. And using this general formula for Legendre polynomial, we can derive the expressions for these Legendre polynomials of degree 0, 1, 2 and so on, or whatever polynomial of degree n is required. Now we have another formula for Legendre polynomial. If you are not comfortable with this formula, we have another formula for Legendre polynomial of degree n. That formula is known as Rodrigues Formula, and this formula is easy to remember as compared to this formula. So we are not deriving or we are not discussing that how this formula is coming out. It is application of binomial theorem, but we are not going into the details of proof of this formula. Instead of that, we will remember or we will write the Rodrigues formula, and we will derive some polynomials, Legendre polynomials, using this formula. Rodrigues formula is given by this Pnx equal to 1 divided by 2 raised to n times n factorial, n times derivative of x square minus 1 raised to n with respect to x, and n can take the values 0, 1, 2, 3 and so on. So this formula is easy to remember as compared to this general formula for Legendre polynomial. So that is your choice, using which formula you want to derive this P0, P1, P2 or whatever polynomial is required. So we sometimes they can ask you to write down Rodrigues formula and write down P0, P1 and P2 using Rodrigues formula. So they can ask you this type of questions also. So Pnx is given by 1 over 2 raised to n factorial, n times derivative of x square minus 1 raised to n. You have to differentiate x square minus 1 raised to n times with respect to x if you are writing Legendre polynomial of degree n, and this is always in the product 1 over 2 raised to n into n factorial. So we try to write down some Legendre polynomials for particular values of n using this formula. Suppose I want to write for n equal to 0, then for n equal to 0 I have P0x equal to 1 over, I take n equal to 0 here. So I have to write 0 everywhere in this expression. So 0 derivative means this x square minus 1 raised to 0, and x square minus 1 raised to 0 is 1, and 0 derivative means we are not going to differentiate this quantity. We will put n equal to 0 here and we will obtain 1. X square minus 1 raised to n becomes 1, and for n equal to 0 we have 0 derivative. 0 derivative means function as it is. Whatever function we obtain for n equal to 0, that we will write as it is. So I have 1 over 2 raised to 0 into 0 factorial. Let me write one more step. 0 derivative, here I am writing x square minus 1 raised to 0. So this is 1, and 0 derivative means this function as it is x square minus 1 raised to 0, which is 1. So we obtain P0x equal to 1, and we have seen that Legendre polynomial of degree 0 is nothing but 1. Similarly, we can obtain this for n equal to 2 we will obtain, for n equal to 1 first, we will obtain Legendre polynomial of degree 1, that is p1x. So in that formula we take n equal to 1, so we have 1 over 2 raised to 1 into 1 factorial, 1 divided by 2 raised to 1 into 1 factorial, and n is 1, so we consider first derivative of x square minus 1 raised to n. N is 1 here, so we put n equal to 1, and this is going to be 1 by 2. Derivative of x square minus 1 is 2x minus 0, that is 2x, and we have 1 by 2 into 2x, 2 will cancel out, and we find that Legendre polynomial of degree 1 is p1x equal to x. So you can compare both the formulas and you can use the formula which is convenient to you. Suppose I write for n equal to 2, then I have to put n equal to 2 in that formula, Rodrigues formula. We have 1 over 2 raised to n into n factorial. N is 2, so we have 2 raised to 2 into 2 factorial, and 2 times derivative d square by dx square of x square minus 1 raised to n. N is 2 here, and let me simplify this. 2 square is 4, 2 factorial is 2, and we write this as d by dx of square of x square minus 1. I have to differentiate this 2 times with respect to x. So first I differentiate with respect to x inside the bracket, and whatever quantity I will obtain, that I have to again differentiate with respect to x. This is now 1 by 8 d by dx, and here derivative of square of x square minus 1 is 2 into x square minus 1 into 2x by chain rule, and this we can rewrite as 1 by 8 d by dx of 4x into x square minus 1, and we can take this 4 outside, so I have 4 by 8 into derivative of x times x square minus 1, and I have product of two functions, so I apply product rule for derivatives. Here 4 will cancel out, I have 1 by 2. First I keep x as it is, derivative of x square minus 1 is 2x, plus x square minus 1 as it is, derivative of x is 1, and now I simplify this. I have 1 by 2, this is 2x square plus x square minus 1, x into 2x, that is 2x square, and x square minus 1 as it is, and we obtain p2x equal to 3x square minus 1 into 1 by 2. So it is easy to derive the Legendre polynomials of different degree using Rodrigues formula also. Here I obtain the formula for Legendre polynomial of degree 2 using Rodrigues formula. So this is another way to derive expressions for Legendre polynomials of different degree, and this is known as Rodrigues formula. So sometimes they can ask you this type of question, that write down Rodrigues formula for Legendre polynomial of degree n, and using Rodrigues formula derive the expressions for p0, p1 and p2. So in that case you have to use Rodrigues formula only. But if they ask you to write down some Legendre polynomials of some degree and they do not specify the formula, then you can use either Rodrigues formula or this general formula for Legendre polynomial of degree n. So this is all about this session. Here we have discussed another way of deriving Legendre polynomial expressions, and that is known as Rodrigues formula, and we conclude this lecture by writing Rodrigues formula again so that you can easily remember. Legendre polynomial of degree n is given by 1 over 2 raised to n into n factorial derivative of x square minus 1 raised to n times derivative with respect to x of x square minus 1 raised to n. So if you are good at derivatives, you can easily derive the expressions for this type of different polynomials of different degree. So I stop here. Thanks for watching.